This is a podcast from the Nuffield Department of Medicine. Dr. Lucy Dorrell tells us how our immune system controls HIV and how we can live with this virus. Hello, Lucy.
Hello.
What happens when people are infected with HIV?
When HIV gets into the body, it infects and destroys the immune system. And it does this by infecting a specialised kind of cell called a CD4 T cell. And CD4 T cells play a really critical role in controlling and regulating how the body copes with a whole range of, with responses to a whole range of microbes. So when these cells are destroyed and depleted over time, they can fall to a critical level, and at that point the individual can become seriously ill just from exposure to relatively harmless germs in the environment, and that's what indicates that they have AIDS.
Can you explain why it can take years for AIDS to develop?
So the body has a very large reserve of CD4 T cells, and although a large proportion of them are destroyed in the earliest stages of the infection, the body can cope for a while, and it takes quite a number of years before they fall to dangerous levels. We've learned from studying a rare group of individuals, so there's a minority of infected individuals who seem to be able to live for 10 or 20 years without showing any signs of illness. And by studying these individuals, we've got some clues as to why it takes a long time to develop AIDS. So clearly the genetic makeup of the individual plays a part, and in particular the genes that code for specific components of the immune response seem to be important in determining how long it takes to develop AIDS.
So what are the most important lines of research that have developed over the past 5 or 10 years?
So over the past 10 years, researchers have started to piece together the process of the immune response to the virus from the very earliest stages of infection. And what's become clear is that HIV is extremely versatile. It seems to be able to cope and outwit just about any immune defence that the body throws at it, and that makes it an extremely difficult target for a vaccine. But on the positive side, there's been huge improvements in treatment. So HIV is treated with combinations of drugs called antiretrovirals, and these drugs have improved enormously in recent years. And nowadays, if you're a person with HIV living in the UK where treatment is freely available, you can expect to have pretty much a normal lifespan if you're diagnosed early.
And how big a problem is HIV in the UK today?
So it's estimated there are about 88,000 people living with HIV, and worryingly about a quarter of those are not aware of their status, so they can unknowingly pass on the infection to other people. And in recent years, the largest increases in cases of HIV have been among heterosexuals.
How does your research fit into translational medicine within the department?
So the goal of our research is to develop a vaccine to prevent HIV infection, and also to use vaccines in combination with drug treatments to try and help infected individuals get rid of the virus from their body. So HIV is an extremely challenging target because it can mutate its genetic makeup, and the way we're trying to deal with this has been to develop a vaccine which focuses the immune response on parts of HIV that it cannot change easily without weakening itself. And we now have vaccines in clinical trials in Oxford, both in healthy volunteers and in patients, trying to test out this strategy, and we have some early encouraging results.
Thank you, Lucy.